Perfect. All right. Thank you everyone for coming tonight. I'm Dawson Wainman. I'm the Director of Student Life for the Frost Student Association. Co-hosting with me tonight is Adam Fallon, the President of the Frost Student Association. And tonight we are joined by Eric Sager. He is the Program Coordinator for the Ecological Restoration Program at both Trent University and Fleming College. And tonight he will be talking with us about lessons from skunks, wumps, and weevils. So thank you, Eric, for being here, and please take it away.
All right. Thanks for having me. And I'm guessing not many people would be familiar with the Wump World, the book, unless they've taken a course with me. In terms of how we can play this tonight, if people just want to text a message, a question or whatever into the chat, I'm happy to answer things as we go along, or we can do it at the end too. So what I want to do is sort of paint a picture, I guess, of both sort of some of the tools that I've used and developed and stolen from others. I mean, we're always stealing and borrowing, that help in terms of conveying ideas. I think the biggest challenge we have as environmental practitioners is speaking to the audience that hasn't been converted. I mean, today I'm largely speaking to a bunch of believers already. But the challenge comes in speaking to those people who may not have the same values as you do. And I've been working about the last 30 years around issues around aquatic plants and lakes, and want to talk a bit about, I guess, maybe the arc that I've gone through personally over that time, but also in terms of some of the language that I've adopted more recently in working with shoreline residents and the general public, and even other scientists, with respect to how we frame this whole issue that we often talk about with respect to aquatic plants and lakes, and it tends to be the invasive aquatic plants and lakes. And so I'll borrow from Wump World. I'll borrow from Aldo Leopold, and then I'll also sort of borrow from some weevils, which were part of a biological control experiment that we did with some plants and some lakes. So I always start out telling my students that I'm a cheesehead, born and raised in Green Bay, Wisconsin. And certainly if you're from Wisconsin, you're indoctrinated into the thinking of Aldo Leopold at an early age. And I had a father who attended the University of Wisconsin, where Leopold taught, and at the end of his career, and so was influenced by him. Didn't take any courses with him directly, but and that certainly gets passed on down the generations. And Leopold, his seminal book is a Sand County Almanac, and it talks about his experiences with an old farm in the Sand Counties, the unglaciated regions of Wisconsin. And he starts out that book with the first chapter called January Thaw, tracing the footsteps of a skunk. So he wants to put himself into the mind of a skunk, and we sort of think of as a book that is as profound as the Sand County Almanac has been. When you first open the pages and you're following a skunk, and it kind of leaves you kind of wondering just what's this guy trying to accomplish. But through that journey of tracking the skunk, he really begins to place people back into nature, I think, and starts that conversation of thinking, my former colleague Peter Lapp would have said the great leveling of the great chain of being, that nature's not there to serve us, but that we are a part of it. And I think Leopold does a really excellent job, almost poetic, in doing that. And And I think in any issue that we work on within the environment or when we're communicating to the sort of general public or to other fellow managers, it's that notion of thinking about the extent to which, there are certain benefits that we derive from the ecosystem, but that the ecosystems themselves have value in and of themselves. And this becomes important certainly in the context of lakes and plants, because plants are often one of the more antagonistic components of our aquatic ecosystems in Ontario, certainly, but and elsewhere. And that question, do we celebrate all aquatic plants? And I think some people do. If you like to fish, if you like to shoot ducks, that some of the services that these things provide in terms of habitat, nutrient sequestration, if you're interested in artificial wetlands and treatment systems and so forth, you're thinking about the value of plants, both in terms of providing structure for biofilms, but also in terms of nutrient sequestration. But then the value in and of themselves, but they're often a component of the ecosystem, right? They're a natural component of lakes. But when it comes to recreation, swimming, and even to a certain extent, people's perceptions of value, property value, then they're despised. And then there's the whole idea of what's the future going to look like? Should we expect more plants? We're moving species around the globe at an unprecedented rate. And these new species come into habitats and they do quite well. They're excellent competitors. We have some species which sort of seem to have become almost naturalized citizens. But yet, we create value systems based on something's native or something's invasive. But we've got native plants that can become quite abundant in and of themselves. And then the other thing to think about is the extent to which these plants are performing services and sequestering nutrients. And in the absence of these plants, then we don't necessarily have clear water. If we look at this patch of northern water milfoil and Eurasian water milfoil hybrid down here, if that's not there, this is probably a highly green and goopy piece of water. So just a quick sort of aquatic macrophyte 101, where do they grow? They're limited by light. They're rarely limited by nutrients. We talk about algae being nutrient limited. They're limited by temperature. And just like, our spring ephemerals and our interior upland forest species, they stratify themselves based on temperature. Depth, they're limited by the water pressure as a big part of that. But then they're also limited by turbulent motion in terms of wave activity. So highly exposed environments have very few plants because they don't have the rooting substrate and so forth. And then there are some other biotic factors. Herbivores chew on them. There's, plant-plant competition. And then they have this unique battle with algae in terms of some species are able to produce chemicals that inhibit the growth of algae, but that system gets overwhelmed if there's a lot of algae present. And so we get epiphytes, which are algae growing onto the plants. We get metaphyton, those long filamentous strands that grow, that get tangled up in the plants, and that can lead to shading, which can then sort of, we think of in shallow eutrophic lakes like we have in the Kawarthas, we think of alternate stable states. Think of lakes can either exist in this clear water state where they're dominated by plants, or they can exist in a turbid state where they're dominated by the phytoplankton. Sorry about that. So, question, do we see temporal changes in aquatic plant communities? Sure. Highly variable at the site level, at the lake level, and we see increases, we see decreases in abundance, and this sort of goes across our classifications of species. So why don't people like plants? Typically, it has to do with recreational opportunities. That's amazing. A phone is ringing and it's not even plugged in. They promote change. There's that reaction. You know, I've never seen these sorts of things happen before. I've been on this cottage for 50 years and we've never had these plants. I can't get my boat out. My grandkids can't swim. It tends to be sort of those sorts of recreational user-based opportunities. There's also sometimes this panic for the ecosystem. These are a non-native thing. So there's changes in the ecosystem. It's affecting what can grow here. And so these lead to reactions. This is a patch of water soldier, which is a non-native plant, only known wild population in North America, actually, down in the Trent River in a region that we refer to as Lake Seymour, which is downstream of Rice Lake. And how do we react? Well, we react often in a bit of hysteria. There's a real panic. And starry stonewort is one of the newest things and it's not that new, but it's the one getting the most attention recently, and it's a macroalgae, so it's not even an angiosperm. And it's clonal reproduction and has these little starry bulbils, which are like a tuber. It's an asexual bud, that overwintering structure, and they can grow from that. And it's quite aggressive, good competitor. Probably one of these things that came in with shipping, and it's probably been around for quite a while. First discovered in New York and Michigan, and then it sort of has since spread around. And they're worried about its consequences to the lake. I think one of the oldest aquatic plant issues we have is certainly related to the Eurasian water milfoil, which showed up in the Kawarthas in the 50s. And it's almost become a naturalized citizens for us. I mean, we have it. It's hybridized with the native, and we'll get into more about Eurasian milfoil later. But every now and then it sort of gets picked up in the media again, and with the whole zombie revolution, now it's the zombie plant because it can break up and all the little bits can form into being another adult plant, and it creates all sorts of potential solutions, from banks of ultraviolet lights underwater, which you're using in Lake Tahoe, to these massive undertakings where they're literally covering the bottom of lakes with burlap as a way of smothering out the plant. And then Stradioides aloides, which would be another example of one of these sort of plants, which has produced quite a response, I would say. Again, this is down in the Trent River and gives you a sense of the degree of infestation. This is a really cool plant in the sense it's perennial. Kind of looks like the spider plants you may have growing in your homes, or an aloe plant. It produces these little offshoots, and then it also produces these tiny little turions in the axils of these rosettes. And those little turions are, again, another overwintering structure. All reproduction asexual. Like there's only male plants, no females, so no seed production. So it's largely one big clonal patch that has spread quite a ways. But think about the areas where it's growing, and think about the areas, what these sort of sites sort of traditionally would have looked like prior to being vegetated again, because historically they were vegetated, but it really isn't until we start to use these waterways that then we start to get concerned. So then we get into these questions about management. and when do we manage, and how best to manage, and is management the right solution? And I think we can, as environmental communicators, we could all take a page from the extent to which the invasion biology folks, the invasive species folks, have garnered a narrative that has latched on, gets buy-in. That's not to say that there aren't instances where we need to manage invasive species and so forth, but sometimes it sort of is done in spite of, instead of, I should say, other actions that we should be undertaking within the watershed. So for plants, we tend to carry out these risk assessments, and we do this for other species. And if the risk assessment, and this is the one that was completed, that we completed for water soldier, and if the risk assessment, deems the estimate of risk to be very high and that the impact to be highly negative, and then you have this sort of degree of certainty, well, then that sort of invokes the next step, which would be some sort of a management. And for water soldier, because the risk was so high, but because it also, its only known infestation in North America was in this one spot of the Trent River, they immediately sort of acted on establishing the goal of full eradication, which is very different from, when we start thinking about some of the other species that we have that are also considered to be problematic. Something like Eurasian milfoil, which is pretty much now ubiquitous across Ontario, but spreading in new lakes and causing lots of concern. They would never consider that sort of a step because it's expensive, but also because of the extent to which it's doable. And then it's, are you just sort of creating a situation where you're going to have a reintroduction down the road? So our attempts then are often justified by this notion of wanting to create something that is more favorable than what the invaded state looks like. And so the tools we have are these harvesters. The latest one that's getting a lot of attention right now are these aerators or jet pumps that people sort of mount on the ends of their dock as a way of blowing the plants away from their swimming area. There's this company Blockade in Quebec, which would like to come into Ontario. They've done some of these applications in Quebec where they lay down these large benthic mats, which is a burlap, decomposable burlap, and then chemicals. And in some instances, we do have some biological control agents. There's the most popular one we're probably aware of would be Weevils, would be the purple loosestrife control. Modern world where climates are changing, species have more international migration pathways than ever before. Was the balance between conservation and creation of new ecosystems include these invasive species? Yeah, that's a very good question. So save that for the end, and we'll come back to that. That sort of introduces the whole concept to us of that, what we distinguish something as being novel, and the creation of these novel ecosystems or hybrid ecosystems, and the extent to which we just accept that they're here to stay and we work with them. And so we'll get to that for sure. But in all of these sorts of instances, we're very quick to manage, but we don't necessarily think about restoration or the post-management plant community. And that's one of the things we're trying to think about right now in terms of in my lab. So with respect to sort of what was tried with water soldier, given that the goal is full site, full eradication, harvester didn't work because it didn't scale. Shade cloth worked locally, but again, it didn't scale. Hand pulling creates a lot of mess, but again, it doesn't scale. So the only thing that scales in terms of large scale, hundreds of hectares, are chemical herbicides. And so that quickly became the path that was taken. And it was fall applications. It was because we only have one licensed product in Ontario, the herbicide diquat. Fall application when most of the natives should be dying back and so not necessarily impacted. Water soldier being a perennial is still growing very well in late October. Thank you very much. So I just got a couple of maps here that sort of show the progression. And in terms of red indicates high amounts. And this is that region of the Trent River, which we call Lake Seymour. And this is Healy Falls, for those of you familiar. And then we sort of get down into this area of Percy's Reach once we get below Campbellford and so forth. And then they call this area Crow Bay. So the majority of it was first found just back here by the bridge of the at Trent River, and then it sort of has flowed downstream and has continued to flow downstream. And so I haven't found it in the Bay of Quinte yet, but I often say it's probably there. We just haven't seen it. But the majority of the chemical application has been in these sort of areas of infestation. So in 2015, the applications were just in this Lake Seymour Reach and then in this Crow Bay Reach. And you'll see 2016, right? We had some efficacy of treatment, and we're starting to see it move slightly farther downstream. 2017, after multiple treatments, hundreds of hectares of treatment, it's reducing. So there is some efficacy of treatment, but it continues to expand farther down. 2018, they hit it hard again, and they had good response. 2020, this is what it looks like presently. But again, it continues to move downstream. So they go from 13 hectares of infestation, mostly in the orange, which are low density infestations, to from 170 at its peak. So there's been some treatment efficacy, but the question is then what's coming up behind it? And that's going to be related to, who can grow and who can deal with those new conditions. But now it becomes who's the most opportunistic to get in and spread their wings. Are we just going to get more of the starry stonewort, which again is a bit of a wildcat because there's no impact of the herbicide on this because it's a macroalgae. We saw some resurgence of wild rice in some of the areas. It came back on its own. Again, another species that's not sensitive to the herbicide, but it's an annual, so it would have been dropping seed, and the seed would be down in the sediments where they're protected from the herbicide. So maybe we're favoring this sort of pre-settlement community. Then we have to think about what's the reaction to that going to be. Well, we celebrate that. And then we have this sort of collection of a very reduced sort of diversity of species, and a very reduced diversity of native species compared to what we would have expected traditionally, because it's a very disturbed region. It's lots of development on the shoreline, lots of nutrients coming down. That's all agricultural land, productive waters, sedimentation rates. And so the species, especially these sorts of species that we find, we would say are very indicative of fairly nutrient-enriched systems. So we're, you could almost argue that water soldier in and of itself was performing a service, right? From the aquatic plant perspective, then there are in other jurisdictions they have target specific chemicals, and chemicals become the most common approach. Just because of their easy ability to scale. But there is some diver-assisted sorts of hand pulling and so forth where they can do individual species. But typically there are going to be native impacts. impacts to native species as well. And so the question becomes, and that's what we're looking at right now for water shoulder, do we see herbicides just promoting, fast growing species, which are the very same species that we manage in other situations? So things like Eurasian milfoil, which can fragment and grow quickly, things like starry stonewort, even to a certain extent, other sorts of Ceratophyllum demersum, which is coontail. It can create these thick floating mats as well. But in that case, we're not, again, the goal was eradication of this one particular species. So it's that whole idea of, like Leopold says, I mean, we need to think like a mountain. So in this case, we need to think like a lake. Think about what's the community of species. And we'll continue with that. Get back to that in a minute. Concerned about use of, so the thing about diquat is a reward. The active ingredient is this compound called diquat. And diquat easily binds to sediments, and then once it gets down into the sediments, it's quickly chewed on by bacteria. So it presents very low risk to the ecosystem, according to the literature. I mean, in terms of it's a chemical. I mean, it still is a chemical, but it's not in the ecosystem long enough to cause harm. As long as it's applied at the appropriate doses. I mean, you always have to say that. But I guess what this comes back to is, will we ever be happy if there are plants? A long-standing discussion in the Kawarthas is, I kind of want these lakes to look like what they have up on the Canadian Shield. Nice clear water, nice, can swim through it. Has anybody sort of experienced that sensation of a couple of plants tickling your belly? Or are you worried about a muskie lurking out and grabbing you? There's all these reactions we have to these essentially wetlands. We want to call them lakes, but let's call a spade a spade. They're wetlands. They're shallow systems. And so that becomes a communication challenge too, in terms of, well, I bought, paid my retirements, I bought this cottage here, and now, the fact that all these plants are here, it's destroying the property values. And that's a very real feeling. It's a very real thought. All right, so I want to shift. Can't see the wetland through the reeds. That's right. I want to shift over to another plant, and this one is more ubiquitous, and this one's really moving around right now in Ontario. And also is one that there's certainly some interesting stories that accompany it, but it's eliciting fear in the sort of Dorset, Huntsville, in cottage country, whereas we don't see it to be too problematic where we are in the Kawarthas. And one of the cool things about science these days is our ability to distinguish between all these different types. So it's all Eurasian water milfoil, but we talk about cryptic diversity now, genotypes, ecotypes, strains. The language has evolved. I think now they call them strains, and these distinct genotypes. And these are all plants that were collected at a series of lakes throughout Ontario, and the sort of the blue represents what we think of as the native milfoil, northern water milfoil. The red is Eurasian water milfoil, what we typically call type 1. Green is another genotype of Eurasian water milfoil. And then those plants that have both blue and red are the hybrids, where the Eurasian water milfoil is hybridized with the native. But then we also, in Ontario, we didn't quite have enough data, but we have this suggestion that we have this third genotype or ecotype that's evolving, and that's this yellow one. And that this yellow one, it sort of seems to occupy those lakes that are up on the Canadian Shield. So if we think of the influence of the bedrock on lake geochemistry, certainly bedrock's not going to be as quick to weather, lower base cation status, and so they tend to have lower alkalinity, soft water lakes, versus our lakes down here on limestone, nutrient rich, lots of weathering coming in from the watershed, very shallow, good mucky soils, and so we've sort of grown with plants from day one, whereas some of those lakes up in the Dorset area have not, but they're learning to. And in those situations, because of the alkalinity of the lake, aquatic plants are often limited by the availability of carbon. So that's where they're different from algae. Algae tend to be very much limited by nutrients, but not as much by carbon, like the angiosperms. And so on those shield lakes, you'll often see emergent plants. You'll see plants, that create floating leaves because they can access that atmospheric carbon as a way of overcoming the carbon limitation in the water. The carbon limitation in the water is just its form. Down here in our Kawartha lakes, there's a lot of bicarbonate coming off the limestone bedrock, and plants figured out how to utilize that bicarbonate in terms of shunting it into photosynthesis. So lots of carbon around, so really, really productive. Well, so that suggests that this type of milfoil, maybe this yellow ecotype, has figured out a way of exploiting that. There's not a lot of bicarbonate up on those lakes, but it's CO2 and can exploit CO2, can access CO2. So overcoming that carbon limitation, perhaps. But it does speak to the extent to which, even within a small landscape such as Ontario, and this sort of typology, this genotype, cryptic diversity, this is something that we see sort of throughout North America. This is the common feature. This is work that Ryan Thune, who's now at Montana State, that we did some work with him, and he's continued to work on it. Whereas, we see this local selection happening, and should we be surprised that species become locally adapted to certain conditions? It just speaks to their ability as good competitors. So this is the sort of range of where we see the lakes that were surveyed, and this was work that Kyle Borman did a while ago. And the different color codes of the different hybrids and so forth, and the different types. And this is confusing. This hybrid is not the same as this hybrid. It's actually the hybrid of the Eurasian and Northern. So we've got this type 2 Eurasian milfoil, which is in a couple of lakes. It's in the Sudbury area, and it's in some lakes around Bancroft. And we have what we think of as classical Eurasian milfoil, which is all this red. And then we get the hybrid, which is the Eurasian milfoil with the northern water milfoil, and different variations of that hybrid. And one of the cool stories that's come out is that the classical invasion story or introduction story for Eurasian water milfoil came in through the Chesapeake Bay and then moved its west up through the different waterways associated with the Great Lakes. And this lineage of milfoil comes east, first introduced out in Washington, came across, we think, from Asia, from the Pacific, and it's marching east. And so, the two shall meet in the middle, it seems like. So in terms of on the landscape, the typical Eurasian milfoil for us is much more abundant, but you go out west and you'll see more abundance of that other genotype. So that's kind of a neat story. And each of these two genotypes, and even our third genotype, will have they're discovering have different responses to management, which is not surprising. Some are the hybrid is very tolerant of some of the chemicals they use in the U.S., whereas this one is tolerant of lower light levels and so forth. So you can create some really interesting ecological stories, life history stories, thinking about those. And that's that classic Eurasian milfoil sort of floating mat which forms on a lake. That this is up near Espanola, Apsey Lake. Performing a service, you could argue, in terms of reducing shoreline erosion from disrupting wave activity and so forth, in response to all the wake boats that are on this lake. But, you know, hard to swim in, right? And wasn't there historically. I mean, that's the other one you'll hear. It was never here. It's this new thing. And so not a lot of inherent competition for it as well. Eurasian milfoil in the Kawarthas has lots of stuff to compete against, but you go into some of these other lakes, because of that carbon limitation, because of where they're located, not so much at this one because they're on limestone, but there's not a lot of inherent competition. So it can exploit lots of new habitat. And the things that are growing there tend to be low growing. And so if you go to the US, they have 30 chemicals that are licensed for application in aquatic environments. We have one in Ontario. If we think of then what are some of the other options that are available, biological control is something that has lots of interest here in Ontario. And in certain jurisdictions in the US, but not as popular in the US because there doesn't seem to be as much concern around chemicals. Whereas in Ontario, there, Shelby asked the question in the chat, you know, are there concerns of the chemicals on other components of the ecosystem? And there are concerns. Even if I say, yeah, they're totally safe, it's like we're still wired to think that, yeah, I don't trust you. You're just trying to sell me a widget, you know. You just want me to buy the chemical. You're the salesman, sort of, so to speak. And so there was a real effort for a while to sort of look at the application of a native weevil, so Eurychiopsis lecontii, which evolves its relationship on northern water milfoil. But then when Eurasian milfoil shows up, it hops over onto Eurasian because Eurasian milfoil doesn't have the same defenses. So northern water milfoil and Eurychiopsis evolve together. And so you could expect that the plant develops defense mechanisms that will keep it sort of, keep the success of the weevil at bay. So Eurasian milfoil shows up in the lake. And now I have choice between a plant that's got a lot of defense mechanisms, but I can kind of survive, or I can go over and graze on this other plant, which looks a lot alike, but doesn't have the same sorts of chemical compounds that may make my digestion, you know, not very enjoyable, and I can skip over there. So it does. And so there were experiments that were done. Ray Newman at the University of Minnesota was the one who sort of pioneered this back in the 80s and the 90s about, well, can we augment the native population of weevils? So rear up weevils in captivity and then release them into these patches as eggs, inoculating essentially the patch to increase the density of native weevils. And really what you want to do is increase the opportunity for weevils to meet. So you put a little Barry White on. You guys, if you know there's a Barry White reference for you, to get them all hot and bothered. And so you get a mating, so you can get more generations of weevil in a given growing season. More generations of weevils means more weevils feeding on stems of Eurasian milfoil, means, you know, less Eurasian milfoil in the water. So theoretically, you know, something that sounds pretty good. But quite controversial because there were arguments that, well, all you're doing is introducing fish food. You're going to put all those, you know, these new weevils in, and then they're just going to get chewed on by fish. it's a buck a weevil. It's expensive. And then the extent to which, how well does it scale to a whole lake setting? So there's a small lake just north of Peterborough, Big Cedar Lake, who hired a company, EnviroScience. There was a company that was commercially stocking lakes, who then went out of business. And then we took it over from an experimental perspective in 2015 and ran for another 3 years. And so stocked a lot of weevils into a lake that had a whole lake infestation of Eurasian milfoil. And if I'm a biological control agent, I'm thinking I'm not going to chew down the crop that is supporting me completely. So you never fully extirpate your plant, right? Because you always need to have some plant there. It wouldn't make sense. And so it's not like chemical applications where the goal is often full eradication. It's not uncommon in the US situation where they will apply chemical for the entire lake to kill all the plants in the lake, with the hopes then that either there's recovery of a more desirable community of plants in the bottom of the from the sediments of the lake, or they'll through active introductions of species, but they'll recreate something that is, i.e., more desirable. And certainly we don't go quite that far. And then there's not all jurisdictions in the U.S. go that far either. I shouldn't paint it all with the same brush. So if we look at sort of before stocking, and this is just milfoil this is a sort of an average of a bunch of sites that we were monitoring over the time. Stem density is approaching 500 stems per meter squared, which is pretty, if you think of that picture I showed you of Apsey Lake, which would look kind of like that. And then, after stocking, it seems to sort of sit around 100 stems per meter squared. So a significant reduction. And this includes local extirpation. So, stock sites were stocked in front of, George's cottage 1 year. And he had a big patch of milfoil there, and the weevils chew it down. But then there's more stems over here in front of Larry's cottage. And so then the next year they'd go over to Larry's cottage and put the weevils there. So it's a moving target. It's like squeezing a tube of toothpaste, and it's just moving its way around the lake. But it is reducing the overall amount of milfoil in the lake. But milfoil is just replacing milfoil because there's very little competition. And again, weevils chew down through the stem, and as they do that, sometimes it creates fragments of milfoil that float around the lake, and then they colonize the neighbors. And after the last year, the last year of stocking was 2016. And then in 2017, we were back surveying the lake, and it suggested, that we were starting to see, in the absence of weevils, we were starting to see this sort of increase in milfoil. And this is an example of you can see where a weevil has chewed on a stem, this little black stuff here. But then there are new shoots that are coming off in between these different sections. So next year's growth, so to speak. So 2017, we started to see resurgence, no stocking. Back 2019, now we're seeing more milfoil coming back, no weevils, no nothing. And then in 2020, this past summer again, it's still staying high. We don't have stem counts in the same way. So it suggests, though, that weevils do work. But remember, it's about $1 a weevil. So 321,000 weevils. Now, these 40,000 weevils, this wasn't $40,000. But when the commercial company was doing it, that was approaching, $40,000. So that's expensive. A lot of money that goes into trying to control a plant in a lake that's fully developed with cottages all around the lake on shallow soils with lots and lots of big places going up. You know, it's classical Ontario, the Ontario cottage story. And so why? You know, that's sort of, I always come back to, well, why? I often get calls to go into lakes to sort of assess, you know, the presence of a plant. They think they have an invasive plant, and I got a call to a particular lake in a certain region. They asked if I'd come by, and I said, well, I'll be in the area, you can come by. And, you know, I go to the address and there's a gate, and I'm push the button on the gate and get buzzed in. The gate opens and I drive down this long driveway, and I go past the tennis courts and the gardens and the ponds full of plants and so forth. It's a private compound, literally. And I go down by this, I'm taken down to by this giant boathouse, which is built into the water. And there's a plant, like literally a plant that they're worried about. And I think, you know, my reaction was, why? Why are you worried about that when, you know, this is what's happened around you? So we seem to have to, so we're not doing a very good job, I think, in terms of framing that narrative. And so that takes us back to the Wumps. The story of Wump World. So Bill Peet writes the Wump World in the 1950s, before Dr. Seuss. Dr. Seuss is the Lorax. He gets the idea after reading the Wump World. And it's the story of these Wumps. They live on their beautiful planet, eating these lovely trees. They get invaded by these things from another planet called the pollutions. And the pollutions come in and conquer and take over. The Wumps are chased down into this cave. And they live in this cave as the pollutions continue to degrade and destroy. This is a book my parents read to me when I was a kid. And meanwhile, the Wumps are down in the cave, and then all of a sudden they notice the silence because it's gotten so polluted again that the pollutions have had to leave. And then the Wumps emerge from their cave after living on a special moss and drinking special moss that can grow underground in the absence of light and drinking water from the springs. And they come out, and the book ends essentially, and you know, in time the murky skies would clear up and the rains would wash the scum from the rivers and the lakes. Tall buildings would come tumbling down, and the freeways would crumble away, and in time the green growth would wind its way up through the rubble, but the Wump world would never be quite the same. And that's classic. That's where we're at, right? Here's your novel ecosystem that Dawson brought up earlier. There's some recovery, there's some inherent ability of the plants to grow, and that's going to provide the same service. The Wump's excited because all he wants is the tree to chew on. That's what he feeds on. But there's going to be all this new structure there, so it's different, right? It's different, and we have to accept that it's different. And we do the same thing to our lakes. We modify shorelines. We put up these large structures, and we create expectations of the lake that are unrealistic. And so then when something goes south, or we think it goes south, our thinking tells us there's harm in the lake. I'm going to do good for the lake by protecting the lake from that evil plant. We don't think about our own actions. We don't think about what have we done. And we don't necessarily understand that, well, maybe that's just the way the lake's going to be. This is a neat picture that Tom Willens, you'll have, teaches over at the university. He uses it and really, you know, we have this whole idea of these new species introductions that come into these ecosystems, and we panic because it's going to change the ecosystem. But over time, ecosystems figure it out and they adapt. Yeah, there's change initially, you know, so we've got this sort of early introduction of, Eurasian water milfoil at a site. We have waterfowl counts that are low and becoming reduced. Then we get this this large infestation of hydrilla, which is a really aggressive plant that's affecting, the central U.S. and the southeastern U.S. But waterfowl have figured out that, wait a minute, there's free food there. It's the buffet. It's like the grizzlies at Banff. Man, if I'm gonna go forage in a blueberry patch, or I'm gonna go to the dumpster. Oh, I'm gonna go to the dumpster because it's easier, it's fatter, it's quicker. Ecosystems adapt, and people don't, right? We don't adapt. And I think by not adapting, we continually create these sort of dead zones because we're always trying to control something that maybe we shouldn't control. Maybe we should sort of sit back, or maybe we shouldn't try to manage on the scale that we do. We should change our thinking. So that's one of the things I've been sort of talking about more consistently, is the extent to which we do have to think about what are the forces acting on our lakes? What are they going to look like? And what should we feel we can expect? And what should we accept? And a lot of that is, just getting used to the fact that this could become a common scene throughout lakes of Ontario, and that it's not bad, right? That it's not bad at all. Anyway, lots of questions in the chat. There's a really long one. Yeah, we can talk about the Rachel Carson thing. Rachel Carson kind of throws out biological control. For those of you who haven't read Silent Spring, she documents the impacts of pesticides, and it's a really profound book in terms of its impacts on policy and setting policy and regulating pesticide use and chemical use. And then she argues, and this is largely in agricultural settings, she sort of, in the absence of chemicals, the farmers were like, well, what do I use? I'm addicted to this stuff and I need to reduce my competition. She argues for the use of biological control. We don't have the same sorts of challenges. The biggest biological control risks that we have in the aquatic world are grass carp. And so, because they're herbivores, and they do use it in some jurisdictions, but they're sterile, the triploid form of the carp, so it can't reproduce, so it just reaches its maximum height and then it dies out. And grass carp, don't feed on certain species, but Asian carp, some of the Asian carp are omnivores. Most of them, I can't remember which one. It's not the silvers, it might be the big heads. But if we think of the Asian carp thing, that's moving up. And they're first brought over to clean up the rice paddies by the U.S. Department of Agriculture down in the southeast, in central south, specifically to harvest plants and chew on plants. And so that'd be a form of biological control. The weevil, because it's a native insect, you're not introducing any risks to other plants because it's evolved on the native milfoil. So it's only chewing on native milfoil or Eurasian milfoil. There is also another weevil that came over from Europe on the Eurasian milfoil, but it's leucogaster, and they've attempted to use that in Europe for some biological control options, but they've explored other organisms. There's groups looking at pathogenic fungus applications. There are groups that have looked at a little diptera larvae that burrows in the stem. There's a little moth. So, there have been other models that have been explored. and in some instances, they've had great success with biological control agents, but it's an integrated pest management approach. So if we think of integrated pest management, it's utilizing, multiple tools. It's not just one. So we've tried to do a bit of that with Eurasian milfoil, looking at some of these revegetated benthic mats, in addition to into a biological control. Question in the Q&A section. Where's the Q&A section?
I can read it out if you like.
Sure.
So she goes, Eric, for those among us that aren't your students, can you touch on your position on so-called invasive species and the creation of novel ecosystems? Why should emerging environmental practitioners be careful to dismiss plants and animals as being strictly invasive or alien?
So novel ecosystem theory recognizes that we live in a melting pot of species, and that species move around. There's immigration, there's immigration, and that some of these new species. So for instance, if we go into a woodlot in downtown Toronto, we would say there's been a sharp decline in biodiversity, even though the richness of a maple woodlot, Leslie and 401, is 10 times the species that we would find, say at Bowmanville. And that's because a lot of the things that are making up that richness are things we would classify as non-native, so we ignore them. But we think of the functional attributes. So we think of the role that ecosystems play, role that species play in ecosystems, in terms of holding soil, providing pollinator habitat, even to a certain extent their intrinsic value, then they have value. And so I'm not as quick to label things as being invasive as being evil as most are. I've become a bit more jaded, I would say. In some cases, some people would say too jaded around reacting to something just because it's invasive. Now, we've attempted to do that with these risk assessment models. I mean, the government recognizes they can't manage everything. And so there are certain things they just won't manage because they don't have the funds to do it. But the more recent recovery of wild rice in the Kawarthas and the southern end of Pigeon Lake, the language that was used initially was that, well, this is some sort of a hybrid rice because it's changed, it's different, it's an invasive variety of rice. It's kind of, we're drawing on the Phragmites story a lot. That native Phragmites is around, it's doing great, it's fine, it's no problem. But the hybrid Phragmites is the one that's really bad. Well, Phragmites has a global distribution. We recognize that it's found around the world. It's just that sometimes it exploits its competitive ability to exploit certain conditions. Another big one getting a lot of attention are cattails. There's cattail, another globally distributed species. You find it all around the world, but we've got things, we've got some strains of cattails which are behaving, quote unquote, invasively. And so species do modify ecosystems. Species do change ecosystems. Sometimes we do need to manage them. If I'm a forestry outfit and I'm dependent upon managing a woodlot and I've got a bunch of dog strangling vine, I don't want that crowding out my regenerating understory. I'm not a big fan of European buckthorn. I mean, I tend to pull that out. So I mean, I think we all have our biases too. But I do think that the day and age we're in right now of come and get a summer job and spend the day cutting down Phragmites just because it's there, only to be replaced by another stand of Phragmites. I'm not sure that's the best use of our limited funds or best narrative that we want to create. I don't, and yeah, I don't, and this, Adam's question, what's the solution with this proposed change of thinking? How can it be achieved? Do you see potential way forward regarding public and government perception? Yeah, somebody once told me that even Republicans or conservatives don't like invasive species. So it becomes traction in some cases just to keep the environment on the agenda. I was at a Great Lakes Governors meeting because water soldier is a listed species in the IJC for the Great Lakes Governors, that board. So a bunch of them came up and we took them out on a tour, and I was talking to one of the advisors to that committee, and he was like, yeah, we can't get any other traction on anything related to the environment, but we can get traction with invasives. So at least that keeps it on the agenda. So there's a lot of policy implications going on as well, but that messaging gets passed down, right? And also we have this like lawns, right? We have this expectation that the lake is just an extension of our lawn and we can do what we want with it. And I run into this sort of challenge. I talk to a lot of lake associations, shoreline residents groups, and I'm like, look, you've got to change your thinking here. Don't worry so much about that. I would spend more attention to what you're doing to the nearshore area, how you're modifying shorelines, how you're bringing in topsoil just so you can cut a lawn, and then ask those sorts of questions and get discussion going at that level if we're thinking about specifically to do with lakes. And how do we measure impact? What is an impact? How do we measure health? Like how do we frame the whole discussion of something that is healthy? So if we look at the picture on the screen, Kyle is swimming in a very healthy wetland right now, taunting those ducks. Whereas the cottagers who are just behind them there were screaming bloody murder because all these plants are there, and they don't remember ever having plants there. I just don't quite understand how they would not, but so that's that notion of language. Well, you're not in a lake, it's a wetland, and that's the way the wetland should be. Well, I don't like it, so I want to pull all those plants out. And so, and they tend to go ahead and do it. So then what appears healthy to them clearly changes the sort of what we would describe as the health of that system. So then what do you do there? Do you put the policy hammer down and start levying fines? Then it just becomes antagonistic. So it's not easy. That's your challenge as the next generation. My generation did really well describing things, but has done very poorly in terms of making change, I would say. We're just regurgitating, the same sorts of studies that were done by, my parents' generation. And it's like we're expecting a different outcome. We're contributing more information. It's not that that's not happening, but in terms of how it's influencing policy, it's not as much. Anyway, any other questions? I'm happy to take them.
So Adam asked, how do we measure impact from one invasive to another?
What's an impact? That's the $1 million question. What we tend to do is we think ultimately the big thing that often regulates is if there's disruption of navigation. That's a big one. So Water Soldier there certainly were disruptions to navigation of the Trent Severn waterway, because you get these rafts of plants growing in the main channel. And even with the wild rice story that we talk about as being a good news story, but they would ultimately manage it if it blocked the navigation. So that becomes a big part of it. Scarcity. How unique is it on the landscape? Cashabog Lake, which is on the other side of Stony Lake, has a plant in it, fanwort, Kabumba caroliniana, which is a tropical species. And it's the only lake in Ontario that has it. And when it was first discovered in the early 90s, it was abundant, but it wasn't fully abundant. But they made the decision at that point, just let it go. Partly because it's not very common, but it's very it's quite abundant down in the US. It's not very common here or in Canada. And within the lake itself, it did change the community, the ecosystem, but the lake seems to have adapted to it. It's introduced some new structure in the lake. Pretty productive lake to begin with from a aquatic macrophyte perspective. But so scarcity in the landscape scale also influences the extent to which we think about plants. Bit of a different story when we start thinking about, an emerald ash borer situation, or some of those sorts of, where the immediate effect is more noticeable. Cashabog Lake, and the plant was fanwort. The genus is Kabumba. So the plant came up from Uruguay. Yeah, and zebra mussels are a great story, right? Zebra mussels, ecosystem engineers saved the day by overcoming the large volumes of algae that are in the water, the free food for the zebra mussels. Create other problems in terms of partitioning where the phosphorus in the system goes. Creates different challenges in terms of filamentous algae growing on the sediments, because there's all this new food down in the sediments that favors things like Cladophora. So if you've been down at Coburg Beach or some of those areas, or you go over to some of the beaches in Lake Michigan, you get these massive rows of dead Cladophora washing up, which is not very enjoyable. And that's a zebra mussel phenomenon. But within the Kawarthas, we've already got an ecosystem that's adapting to chewing on these mussels, right? They're eating it. It's free food. So you got pumpkin seeds, another non-native, which use that as a food source, and other species as well. And so they're there, but they're not as abundant, when I first moved up onto the shores of Pigeon Lake 20 years ago.
Any other questions from anyone?
What's the paper about zebra mussels and other introduced mussel? Quagga, be quaggas, eh? My favorite invasive. Garlic mustard, because you can eat it. Makes good pesto.
All right. Well, if there's no more questions, then I'd like to thank you very much, Eric. You certainly got us thinking differently about our ecosystems. I really like the quote that they're not lakes, they're wetlands.
Yep.
It definitely made me think about our ecosystem a lot more. Ontario is more of a swamp than we think. But yeah, thank you very much. And thank you all for coming tonight. And this will be posted to YouTube shortly for all to enjoy.
All right. Thank you.
Thank you.